Hey guys, so last video about photosynthesis, I wanted to talk about C3, C4 plants and the CAM plants, CAM plants, and why they do these things. So let's talk about C3. C3 is more of a temperate plant that's like our trees, like a sycamore tree here. Sorry. And the C4 plants, it's more like a corn plant. So corn can live in big fields exposed to the sun, so it's more used to drier climates. And the CAM plants, it's desertic plants. So those C4 and CAM will do something different from C3. C3 is just doing well in cool and moist weather because it does everything during the day and just works everything in your mesophyll cells, which are just the cells that are under the skin of the plant. So you have your seal for the carbon reaction. The carbon fixation takes place from CO2 getting through the stroma, and you do a Calvin cycle. You make sugar there, and it works well because it doesn't dry up, so you can keep the stroma open. How stroma being the holes in the leaves, allowing the oxygen and carbon dioxide to get in or out. However, when you plant like the corn plant, a C4 or a cacti, a cactus from a desert area, you are exposed to drier conditions. So in case of a C4, it's just drier. So you're going to separate the cells that do the Calvin cycle from the cells that take in the carbon dioxide. Because if you expose all your cells widely to the stroma and the outside, they're all going to lose a lot of water by evaporation. CAM plants do things even differently. They do the entire carbon reaction at night. So they don't need actually to open the stroma at all during the day. So they don't need to dry out. What does that mean? Well, if you look at your plant, if you cut a piece of sycamore, that's a maple tree leaf. If you cut that leaf and you look through, there is the top layer, the waxy layer, and the waxy layer there. All those link, by the way, they're all tight junction, if you remember what we talked about before, keeping the air from coming in, which is why the stoma is where only, I think it's stroma, I should have an R here, maybe a typo, maybe I just too French here. The air goes through the stroma opening, and the air is widely like a lot of cells are widely accessed by air, right? You have off to the bundle sheath cell that are around the vein where it's carrying all the nutrients, and the mesophyll cell is a little bit further away. But the Calvin cycle can take place anywhere here because you have carbon dioxide accessing everywhere. And it works because you don't lose a lot of water due to the fact that those C3 plants live in areas that are moist and cool. However, when you C4 plant like a corn, you live in an area that's a little bit less forgiving. So your cuticle is maybe tighter and your stroma only open to short areas here, close area, when carbon dioxide is uptaken by mesophyll cells, but the bundle sheath cells are not exposed to the air, they don't lose water easily, and the carbon dioxide is transported to those cells secondarily where the Calvin cycle takes place. That works well when it's dry, but not too dry, right? Corn, it lives in dry area, but it's not a desert. Now, if you're a desertic plant, keeping those stoma open during the day, it's like death sentence because you're gonna dry out super fast. So the CAM plants, what they do is they use their leaves for cacti, for example. The leaves are the spines, by the way. So that's why the cacti has a lot of photosynthesis taking place in its trunk. That's why it looks green and not brown like trees, because it doesn't have a lot of leaves that are wide. It's all the spines that are really small because it doesn't want to have a lot of surface exposed to air and lose a lot of water. So during the day, everything is closed up, and all it does is just the photosynthesis. It uses some water to make some energy in form of NADPH and ATP. At night, it opens up those stroma that are on the spines. Remember, those are the leaves. And there are stroma also on the main part of the cactus. It's not bark, right? It's a cactus. That's why it's a cactus. It doesn't have bark because it does photosynthesis everywhere. It's green everywhere. It opens up at night where the temperature is way lower with less risk of losing all its water, and then does all the Calvin cycle at night. So carbon reaction are light independent. So it doesn't mean it has to happen at night, like C3 and C4 plants do the carbon reaction during the day. But the CAM plants have to do it at night because if they were to do that during the day, they would open up the stroma to get the CO2 in. Problem is all the water is getting out. So it's an adaptation to the really drastic environment of deserts. And there you have it. That's why campland, that's how they divide their labor temporarily rather than spatially like the C4 planes do. And the C3 plane, they don't divide nothing, they do all at once during the day. Okay, that's all for it. That's the end of photosynthesis. I'll see you guys next week. Until then, you take care. Bye bye.